Hey everyone, welcome back, and today we will be doing another lead code problem 661 image smoother. This is an easy one, but it is ranked as easy, but this is not an easy problem. An image smoother is a filter of a size 3 by 3 that can be applied to each cell of an image by rounding down the average of a cell by 8 surrounding cells, the average of the 9 cells in the blue smoother. Like this is, you can say they want to do when they mean by applying a smoother, or you can, yes, they call it the smoother, the rounding down the average of the cell by surrounding 8 cells. So if the cells are not present, for example this 5 does not have surrounding 8 cells, then the average is not going to be considered of the other 5s. Like these in the red smoother, like this 25, it does not have its own boundary cell uh, to cover it up. Like these fives are just ignored, and we will just take the average of these four. So that's it. And now if we see the example, so the given the matrix mx and integer representing the grayscale of an image, return the image after applying the smoother effect to each cell. So we want to apply the smoother effect to each cell. So if we see this example one, we have three ones in this in this. Like if we take this one, this cell should have other cells, but they are not present, so we'll just ignoring them and taking the average of these four. These four have the sum of 3, but the average is going to be 0, because like this 0 0 0 2 2 and 0 and 2 2 are going to return the average of 0, which will be just 0, because we know that 3 is not divisible by 4, so 0. And it is the case with all other elements, especially the middle one. If you can see, like there are 9 elements and now we have 0 at the middle, so it to have 1 1 properly in each cell, we are going to have 1, or required to have 1 in the middle. But since we do not have 1, we are going to return 0 at each location. You can say, because every cell is just not having the average to put something there at a certain location. To things make things more clearer, we have example 2. So take the blue smoother effect on the cell 1. This is not going to be the blue smoother effect, this is going to be the red one, in which we ignore the other ones. So this is going to return the average of 550, these four cells, and their average is going to be 137. So we'll be returning 137 at the position 100, and doing the same with all other hundreds, because they are basically surrounding by the same element: 200 200 200 200 200 250. So that's why they said 00 02 20 and 22 are the same. And now if you look at 200s, they are also the same, but they are in the middle of the corners. So this is also the same case. And then there comes the 50, and if we take the sum of the 9, these 9 blocks divided by the 9 elements, or the 9 number of counts, you can say, then we are going to return 138 at that location of 50. So first of all, we will make a result list, and our rows, we want to check how many rows we have, and our columns, we want to check how many columns we have. If we can just check it like this. Okay, so for every index we will pick, and every row we will pick. So for I in enumerate, we will enumerate in image, and at each point we will just result dot append it with an empty list. So for columns in columns, so for columns in column, like column in enumerate, we will enumerate it in the row. And now we want to make the sum is equal to 0, which we, and the count is also equal to 0. we want to move in the row. So first of all we will make a dx pointer in, you can say, a range of -1 till 2, and a dy to move in the dx to move in the row, and dy to just update our column, and range till -1 till 2. Okay, so we will check if r plus dx, r is the index of the row and the dx which at the certain location we are at. So if it is greater than 0, because the index is obviously start from 0, and r plus dx should be less than the rows, it should not be exceeding the limit, we should be staying in bounds and doing the same with the columns. So c will be holding, you can say, or controlling the column, so we'll be having c, and dy less than, it should be less than columns, and also should be greater than 0, greater than or equal to 0. Okay, so we are done, and now we can just sum the image at the location. So dx plus r and dy plus c, and increase our count, which we'll be using to take our average. So in our result, in the last result, which, which we have on the very end, we are going to append the sum with the average of count. So we have sum in S and the average will be taken with counts, and after that we can just return the result. And let's see if this works or not. And this works, and let's submit it. And that's it.